to our presentation on genetically modified organisms, or GMOs. First of all, what is a GMO? Well, according to Rukisa Yali at the Ethiopian Institute of Agriculture and his colleagues, GMOs are organisms in which their DNA has been altered by genetic modification. And importantly, they do not originate naturally, but are instead a result of direct human interference. So the conundrum in GMOs lies in the fact that although they may be lucrative and helpful, there's a great amount of concern about their effects on human health and ecosystems, which leads us to our problem.
The main problem we have identified regarding GMOs is the uncertainty surrounding their use and release into the public. There have been many doubts about their implications that have made many skeptical of their safety, and many peer-reviewed authors have picked up on this. Specifically, Rachir Rahman, who is a researcher at the Department of Epidemiology and Biostatistics at Indiana University Bloomington, designates GMOs as an imperfect technology with risks of toxicity, allergenicity, and genetic hazards. And this view is also shared by the public. The Nuffield Council of Bioethics says that controversies due to European skepticism have prevented some countries in the EU from adopting GM crops. However, though there are obviously risks, some people believe that the trade-offs of GMOs are worth it. David Silberman, professor at the Department of Agriculture and Research Economics at UC Berkeley and associates write, GM crops would increase yield by 21.6%, reduce pesticide quantity by 36.9%, reduce pesticide cost by 39.2%, and increase farmer profits by 68.2%, showing that though there are uncertainties, the problem stems deeper into the fact that some believe the trade-offs are worth it, while others believe they aren't.
So this brings us to our first solution, which is greater implementation of government regulations regarding the use and production of GMOs. And if these regulations were implemented, they would help prevent any of these future health and environmental problems. And these regulations will also boost public confidence in the GMO industry. Coming to our limitations, it requires reform and lots of legal work. And so coming with this means that these stricter mandates and rules, certain farmers, especially resource-poor farmers, will be unable to comply or unwilling to, as they may not have the resource access to adopt these regulations. In the Nuffield Council for Bioethics states, it would be extremely difficult for most developing countries to comply with strict EU requirements for traceability and labeling, as many of these developing countries do not have the necessary infrastructure to meet these requirements. Another problem stemming from these regulations is that increasing them would reduce the capacity for global trade, as the Genetic Literacy Project, a nonprofit organization encouraging awareness in the public of biotechnology and genetic literacy, affirms that GMOs are currently banned by many nations, with only 29 nations currently growing them. And this means that with these current regulations and challenges, many countries have already been dissuaded. And so increasing this would mean that the challenges are only increased and would dissuade countries even more from adopting GM crops. And another problem stemming from these regulations is that the GM technology will evolve faster than these regulations do, as it will take time for legislation and bills to be passed. Plus, the generalization of these regulations will not account for specific plants and plant properties, and this in turn will cause future problems. Coming to the implications of our solution, the Directorate General responsible for delegations and policies within the EU writes that GM crops from an economic point of view might be more suited for certain developing countries with strong governments, as these nations with these strong institutions would easily be able to adopt these policies, and thus this would mean that these nations and these populations would have access to this quality GM food. In addition, with the more measures in place, it is less likely that an unwanting or an unwilling customer will accidentally purchase and consume a GMO, and these farmers will be unable to overplant these GMOs, which have unknown side effects at the moment. Kim Anderson, an economist specializing in food trade, found that the EU has had success by requiring labeling of all food items containing 1% or more of genetically modified material. And now these customers within the EU have the ability to discern between transgenic and non-transgenic foods. And so this is instilling trust within these EU customers, as they can now tell what is in this food. And so reform of regulations can stop the uncertainty and allow for time to show the results.
The second solution that we propose is increased testing. Increased testing goes concurrently hand in hand with the ability to eliminate uncertainty. both in the public and the governmental sectors, as prolonged and thorough testing is key to have real-world data and implementation that guarantees future success for these communities. Furthermore, Nina Federer, a PhD at the Rockefeller University and science and tech advisor to the United States Federal Secretary of State, illuminates that there are going to be impending shortages in agriculture, writing that the expected pressures on water availability and increased temperatures present crucial challenges to agricultural researchers to increase crop and water efficiency, including heat tolerance. Thus, this increased testing is key for the GMOs to have effectivity in the real world, and more prolonged data and testing is key. She also goes on to write that in doing so, she can usher a new era of sustainable agriculture, which is both cost-effective and environmentally friendly. This can be achieved, however, in contrast, GM crops have also been seen as a health and human safety risk, as A.S. Bala and Tara Anil Kumar of the Defense Research Lab in Mysore, India, write that GM crop bean plants specifically were found to have increased cysteine and methionine products, which are both highly allergenic proteins for human safety. Thus, by increasing the amount of GM crop testing, we can provide better efficiency and regulations that prevent such proteins from popping up. Now, transitioning to the limitations of increased testing, Laura A. Marison, professor at the College of Environmental Life Sciences at the University of Rhode Island, adds the comparison between the cost of benefits and analysis of GMOs. She goes on to state that this is concurrently based on what organism is modified, what traits within the organism is modified, and what environment the organism occupies, providing that GMOs are quite complex when it comes to scientific methodology. Furthermore, she emphasizes that scientific research has in fact been done on GMOs. However, there is still exponentially more research that still is lacking and that will require to be done. She also states that a full-scale study on analysis may be a stretch for developing countries planning to implement GMOs, thus making actual implementation in larger countries key for global follow-on, because these larger companies can increase trust in these smaller institutions as they lack infrastructure in agriculture. She also states that a scientific community may feel contradictory beliefs regarding further research, as a singular stance on one scientific paper or study is improbable, and there will be coinciding beliefs. Finally, tracking onto the implications. Specifically, Dan Brosh-Mujito, Master's in Agricultural Policy from the University of California, Berkeley, writes that greenhouse gas emissions by implementation of GM crop in Europe could reduce greenhouse gas emissions by almost 33 million tons of carbon dioxide equivalent per year. As stated, this can usher a new era of green agriculture, which states that by having more testing, we can have an accurate collection of data. This includes more scientific paper and accurate research. This in turn increases governmental trust, as these governments have infrastructure and research to base their findings off, and therefore can implement more accurate reforms. This in turn will also create a more agricultural transition that is most cost-friendly, environmentally friendly, and sustainable in the future through the implementation of this GM crop technology.
In all, the superior solution is increasing the testing of GMOs. As Dr. Anne Engelberg-Meir, the director of the Jenner Center of Biosafety, states, testing is the way to reduce uncertainty by GMOs by making more clear both the positive and the negative effects of each GMO. Testing also furthers green agriculture by increasing the potency of GMOs, which in turn makes GMOs more tolerant and thus sustainable. It also reduces the need for other resources, such as herbicides and pesticides. Testing is also more implementable because it requires a lot less direct legislation, but also gets more direct work done. And finally, and perhaps most importantly, testing is hyper-specific. It looks at each GMO in a case-by-case standard and tweaks each GMO to be as efficient, effective, and safe as possible, instead of the one-size-fits-all hopeful reforms that regulation increases can provide. And therefore, as Dr. Meir states, in order to combat uncertainty, testing is the optimal solution. Thank you, and here's our work set.
Terrific, thanks guys. I got a few questions for you and then we will wrap this up. Okay, first, Hugh, what's an example of a compelling argument from one of these guys' reports that you guys decided not to include as part of your presentation, and how come?
Okay. Could you repeat the question one more time?
Sure. What was an example of a compelling argument from one of these guys' reports that you guys decided not to include in the final presentation, and how come?
So a very compelling argument from Gavin's paper. Gavin's paper was specifically the economic lens. And what we wanted to capitalize is on the fact that these developing countries, through the implementation of GMOs, need both economic progressivity and safety benefits. Thus, Gavin wrote about this technology or the golden rice implementation in India, which benefits these malnourished communities by providing them with this rice or wheat grain that increases vitamin A deficiencies. However, we actually excluded this argument as it was getting too hyper-specific, and the solution, therefore, was solved in our solution. As we explained, that increased testing goes hand in hand with the solution, as the only reason that such technology isn't being implemented worldwide in these developing countries is because there's this tag-along uncertainty. And thus, by increasing this testing, we can have more governmental trust, and that leads to more trust in the people itself.
Okay, terrific. Well, follow it up with Gavin. So, Gavin, how did the group decide to include or exclude Hugh's perspective or lens in the overall presentation? What part of that was Hugh's?
So Hugh actually focused on the ethic. He was a futuristic lens, but he also explored how some of these developing nations, they do not have the necessary infrastructure to actually implement GMOs. And so he came in the solution one, requiring reforms, as he explored how some of these reforms will be able to stop some of this uncertainty, prevent farmers from actually overplanting these crops. However, it wasn't our optimal solution, as he found that most of these countries and specific farmers won't have the actual available resources to implement and comply with these regulations.
Okay, terrific. Okay, Vincent, give one specific way your thinking changed as a result of what Nevin said in his paper. How did that influence you and your thought process?
Right. So Nevin's paper was focusing on the ethical lens, so it explored things like morality, how it would impact specific communities, specific peoples, and the specific implications that came out of a more generalized implication of GMO. So my paper was more scientific. So my research was usually contained to what studies had shown, and specifically the implications shown through studies. However, I did not really delve deep into how those implications would impact the world and impact things like marginalized communities or less developed countries. So that is what Nevin's paper really delved into, and it really made me question, sure, we have these scientific stats, but how is this actually going to be practical in the real world? How is this affecting things, and what are the ethics behind it? So the ethical lens really made me delve deeper into the implications, and this really helped when I was exploring the problem, as it made me broaden my understanding of how the risks and the scientific nature of the risks impacts people in the real world.
Terrific. Thanks for that. And then finally, Nevin, and this is a common question, you've heard it before in other groups. If you guys had a fifth team member, right, so would there be room for an additional perspective that you think would really benefit your presentation? And if so, what would it be?
Well, yes, it would be wonderful to have one person who had a political lens looking at this, because so far we only have two different conditions for the countries in which the GMO reforms are actually being implemented, which are developing countries and already developed countries, and this is just an economic status. However, we do not have anyone looking at the governments of the countries and how they could implement these GMOs and the policies, and whether they would or not, and what types of governments would synergy best with them. And therefore, a political lens would be very useful for this issue.
Excellent, excellent. Thanks, guys. You're all done.